Hello, everyone. Today we are going to discuss the quadratic formula. So this is 8.7 in your notes, and it's using the quadratic formula. So to solve the standard form of a quadratic equation, x squared plus bx plus c equals 0, we can use the quadratic formula. So you should use this when completing the square is difficult or when you can't factor. Now, important note, quadratic formula will always work, whether it's factorable or not. So here's our quadratic formula. It is x equals negative b plus or minus the square root of b squared minus 4ac. This is very important, and you should memorize this. You must memorize this. So the first thing we're going to do to solve example 1, x squared plus 2x equals 3, is we're going to rewrite it in standard form. So I need to subtract 3 from both sides. So that gives me x squared plus 2x minus 3 equals 0. Now that it's in standard form, I can tell that a, which is the coefficient of x squared, is 1, b, coefficient of x is 2, and c, the constant, is negative 3. So now I'm going to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I substitute my values in. So it's negative 2 plus or minus square root 2 squared minus 4 times 1 times negative 3 over 2 times 1. So now I can use my calculator to simplify that, and didn't tell me to round, so let me see. So I can either use my calculator, or I can say negative 2 plus or minus, and I can do what's inside here. So 2 squared is 4, minus 4 times 1 times negative 3. So that actually works out to be 16 in there, over 2. Square root of 16 is 4, so that's negative 2 plus 4 over 2, and negative 2 minus 4 over 2, because the formula has the plus or minus. So negative 2 plus 4 over 2 equals 1. Negative 2 minus 4 over 2 equals negative 3. So our solution set is 1, negative 3. So now to solve this next one, again, I put in standard form. A is 1 because it's the coefficient of x squared. B is negative 6, coefficient of x, and c is negative 2. So I do my formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And substitute. So it's negative negative 6, so that's really just 6 plus or minus square root. It's important that I put that negative 6 in parentheses when I'm squaring it. Minus 4 times 1 times negative 2 over 2. Again, I'm going to simplify what's underneath my square root. So that's negative 6 squared is 36 plus 8. So that's 44 over 2. 44 is not a perfect square. So this tells me to the nearest tenth. So on my calculator, I'm going to do 6 plus the square root of 44 all over 2, and 6 minus the square root of 44 over 2. I'm going to do those to get my answers. So I used my calculator, and my answers are 6.3 and negative 0.3. So I want you to pause, and I want you to try 1, 2, and 3, and come back and check. Okay, so number 1, A equals 1, B equals negative 3, C equals 2. Substituted that into my formula, which is negative b plus or minus square root b squared minus 4ac all over 2a. I got 3 plus or minus square root negative 3 in parentheses squared minus 4 times 1 times 2. And underneath the radical, that equals 1. So it's 3 plus or minus square root of 1 over 2, which gives me the answers of 2 and 1. Number 2, again, I added 16. So I got x squared minus 8x plus 16 equals 0, which means a equals 1, b equals negative 8, c equals 16. I substituted that into the quadratic formula. So x equals 8 plus or minus the square root, negative 8 squared minus 4 times 1 times 16. Underneath my radical, that equals 0. So it's really just 8 plus or minus 0 over 2. So that's just 4. There is only one root when underneath the radical equals 0. Number 3, again, I added 1 to both sides. So a equals 16, b equals negative 8, c equals 1. Substituted. Again, underneath my radical is 0. So x equals 1/4. So now we're going to skip 4, 5, and 6 to do tomorrow in class. I want to talk about the discriminant. So the discriminant in the quadratic formula is the expression underneath the radical. So the discriminant is really just the b squared minus 4ac part. The discriminant can be used to determine the number of real solutions for a quadratic equation. If the discriminant is less than 0 or negative, there are no solutions because there are no negative values that I can take square root of and get a real number. If it equals 0, there's one solution. And if it equals positive, there are two real solutions. So we can use the discriminant to identify how many solutions. So the first thing I need to do is I need to write it in standard form. So in this case, for number 1, I need to subtract 4 from both sides. So that gives me 12x squared plus 5x minus 4 equals 0. I still need to identify my a, b, and c. So a equals 12, b equals 5, and c equals negative 4. I'm going to substitute into just b squared minus 4ac. So that's 5 squared minus 4 times 12 times negative 4. I'm going to do that. So on my calculator, I do 5 squared minus 4 times 12 times negative 4, and it equals 217. Since it is positive, the equation has two real solutions. So example 2. Again, I need to make it equal 0, so I add 4 to both sides. So I get 2x squared plus 3x plus 4 equals 0. So that means that a is 2, b is 3, and c is 4. I substitute, so it's 3 squared, because b is 3, minus 4 times 2 times 4. So I do that on my calculator. Which gave me negative 23. Since the discriminant is negative, there are 0 real solutions. So I want you to pause, and I want you to try 7, 8, 9. You're just identifying how many real solutions. So number 7, a equals 3, b equals 2, c equals negative 3. I substitute those into b squared minus 4ac. So it's 2 squared minus 4 times 3 times negative 3 gives me 40, which is positive, so there's two solutions. Number 8, a equals 3, b equals negative 7, c equals negative 8. I substitute that into b squared minus 4ac, remembering to put negative 7 in parentheses before I square it, and I get 145, so that's positive, so there's two solutions. Number 9, a equals 2, b equals negative 10, c equals negative 9. Again, I substitute that into b squared minus 4ac. Remembering negative 10 in parentheses, I get 172, so there's two positive solutions. So that's the end of our video today. We will finish the rest of these practice problems tomorrow in class.